36. Your 5 is your 360. Alright? And then after that, your 6, your 7, your 8, you're adding the 0. So basically you're hitting like 5, and then you have this exponent thing, plus 1, plus 2, plus 3, plus 4, plus 5, and it's just zeros. It just counts as a 0 to the thing, right? So that right there is another mathematical component of the Kenny color spiral. So you facilitate whatever one you choose, almost. Sometimes you go and check at both, because each one can have its own color alignment by stating how many you're going, right? Because the other one goes with its separation is 1 degree of separation is the 3, because you're going off of 3. Remember, you're applying whatever to it, 3. And that because you're doing that because, okay, I'm basing this on my primary of color, and this is a Kenny color spiral. Alright? Yeah, that's how this works. So, we're applying color to this origin, this point, this definition, this X. And then we're applying our application to this color in there, saying, okay, this is yellow, this is blue, so now we have defined an X, so some separation, no matter what, an X and a Y. X and a Y, right? So this way, I guess, because if this is X and this is Y, we have our red, yellow, or blue, right? So right there, we have that separation off from wherever red is. So even if it's down here, yellow's over here, blue's over here, alright? So red's always right here. And it doesn't matter if yellow goes here and blue goes here, because when you go to the balance going both ways on the Kenny color spiral, that's how you do that. Alright, that's one of the ways how you do that. Okay? Because remember, there's more than one color. So, as you go that way, applying, this is my red here, this is my red here, and this is my yellow here, this is my blue here, and then switch it up where this is my blue here, this is my yellow here, this way, that way, by doing math of putting this here, dot, dot, dot. Because remember, we're saying we're aligning these other cups' colors later on, right? And so if we're going to apply a definition on a graph and say, okay, I'm going to take this graph that is, which is three-dimensional, alright, and it has a spiral of color. And in each color, certain spots will sparkle or shine that will represent a mathematical alignment, a mathematical formula that proves that it is holding on to its base color based on its balancing of its primary color, basically, its lower level of spiral. So no matter how far you out are you on the 360, because remember, everyone starts with, each color definition of everything starts with the 360 here and the 360 out, right? No matter what. So that right there places you like here. So you're like, okay, if this is my red right here, and this is my yellow right here, this is my blue right here, and I'm going to green, directly opposite of red, I'm going 180, all right? I'm